Okay, so let's, grade 12s, let's get started on sequential file handling. Okay, so this is our new grade 12 unit that I'm going to introduce to you guys right now. It's going to probably challenge some of the things that you take for granted when you hear of files in computers. Okay? Now, the thing about your programming up to this point is every piece of data you've stored has been temporary. It's been stored in the form of a variable or an array or a class or some sort of complex data structure, but it is only available while the program is running. The second your program stops, any of that data is lost. Or if, say, the computer gets unplugged, the data is lost. So the problem with these data structures are they are temporary, and they are also defined as volatile. They're volatile data structures. If you want to permanently store data, you're going to need to write your data to a permanent data structure, and typically that is known as a file. Okay. Your computers use a system to organize the files, and any computer needs that type of system. Whether it's a computer or an MP3 player or a phone, it needs a way to organize the files. It needs a system of organization. Most, when we talk about computers, store data on some sort of permanent or persistent storage device, which could be a metal hard disk, it could be a solid state piece of memory, it could be something as simple as a USB key, or if we want to do a little bit of throwback, a floppy disk or a CD disk, some sort of permanent storage device. But when it saves it, it gives the file a very, very specifically unique name. Okay? Now, the way the naming system works on computers generally follows this convention. Okay? And I think you probably knew this already, that there was the name itself. Like, let's say you're saving a picture of your dog, right? And you called it Fluffy, right? Fluffy would be the name of the file. But there's way more to it than that. What you probably know, although it's not often something you type in when you save that picture, is that that file has what's called an extension. So for example, for a photo, it might be something like .jpeg. Okay, that extension is used by the system to identify what kind of file it is. So that if you say double click it, or something like that, it knows, oh, this is a picture. I should probably help my user by launching a photo viewing program. It makes it easier for them, rather than them having to launch the photo viewing program and then try and find the file. But as well, a part that's often something you don't think about is the path to get there. Where is that picture saved? Where is that file organized into? And that usually involves some sort of folder system generally. Okay? That folder system usually starts with a single letter, usually a letter that's identified for the drive itself that it's stored on, so the C drive or the D drive. And then depending on the system, I'm going to use, say, Windows, for example, it would be a colon and then maybe a series of slash characters to indicate the directory. Okay? We often just call that the path. But when we think of files, we want to also think of these three things in a slightly different way. Okay? So some terms you're going to need to become aware of. Directories start at what's called the root directory. That's the beginning directory. Okay? Then subdirectories will come out of this, or sometimes we use the term folders, will come out of that, and they're often separated by a backslash, or in some systems, a forward slash character. Okay? For example, in Unix systems, they use a forward slash system. Okay? Then the file name. And generally, there are some rules on all these things. The rules have opened up over the years. If you think of that old computer I have in the back corner, when I use that computer, you're actually only allowed to use 8 characters when you saved a file name. And none of them could be a space. So you have some really unique names that would come out of that time when people would name their files. Okay? But even in today's system, there are certain characters, like you can't use an exclamation point and stuff like that in the name of your file because it doesn't allow those characters. Okay? Yeah. Okay. And then the extension. which also has its own limitations. It used to be that the extension was limited to only 3 characters, which is why JPEGs are named JPG, and then sometimes you find them on the internet, they're called JPEG. Well, it's actually an acronym. It stands for Joint Photograph Experts Group. That's what JPEG stands for, which should include the E, Joint Photograph Experts Group. But when they first created the format known as JPEG format, and they created the extension, they weren't allowed to put an E in there because they were limited to 3 characters. But now they're not limited to 3 characters, and that's why now it's JPEG. If you know anything about web pages, that's why some web pages are HTML and some are just HTM. Okay? There's an extension sort of legacy there with some programmers. Okay? But here's the term I want you to become more familiar with. We're going to now call those 3 parts of the file name the first, middle, and last name of a file. Okay? So, here's an example. That's the path name to this file. Okay, starting at the root directory, the single letter, the colon, the slashes, the folders, then the file name itself, and then its extension. Okay? But you could also call this file's first, middle, and last name. Okay? Because here's the rule that most systems use. The rule is no 2 files can have the same first, middle, and last name. They have to be unique. Now, what that means is that 2 files could have the same first name. Like there could be inside of C My Documents multiple files there because they all have the same first name. They could even have the same first name and the same last name. So in other words, you could have a whole bunch of text files inside of this folder. You could have 2 files that have the same first name and the same last name, or sorry, middle name. So you could have inside of C My Documents, you could have employee record.txt, and you could have employee record.jpg and employee record.doc. That wouldn't violate the rule. Okay? As long as you don't have 2 files with the same first, middle, and last name, the system allows it. Okay? Because otherwise, it wouldn't know how to organize those files because they'd be too identical. So no 2 first identical middle and last name on any system. And that's Mac, PC, Unix, whatever. Okay, so these files are organized into various formats. But now when we get down to the nitty-gritty, how does a file actually work? Okay? What we're going to look at is a type of file known as a sequential access file. Basically, it is a text file. Okay? A file of purely plain text. Now, does that mean it could never be a picture or anything like that? Well, no, not necessarily. But that's the format we're going to start with, is this sequential access file. Okay. So what sequential files do is they store basically characters that are available in the ANSI table. Now, ANSI, you may look at there, is a subset of the ASCII character set. Okay? And basically, if I just flip to the next page, it's a bunch of collection of characters. Okay? It's actually the first 127 characters from the ASCII table. And you may recall, I'm just going to turn the light on for a second. That's a chart of the ASCII table right in the back of the room there. But there are characters within that table that are not standard from computer system to computer system, Mac to PC to other systems. Okay? So ANSI is the first 127 for sure are part of every system. And it's often a lot of characters that are beyond the scope of the keyboard itself. Like when you click keys on your keyboard, you have a certain number you can present, but there are certainly way more. Okay? And one of the simplest ones you could think about is the Enter key on your keyboard. The Enter key on your keyboard seems like a fairly simple key to just think about. But in fact, it's not. There's a little bit to it, more to it, than just hitting Enter. Okay? And to show that, did I launch it? I thought I launched it. I just want to, sorry, I should have had this up. I just want to draw a quick diagram And I want you to just for a second stare at that enter key on your keyboard. Not the word enter, but the character that's underneath it. It looks like this, right? That's the way they drew it. And now I have to ask you guys if any of you have ever seen an old mechanical typewriter. Not an electric typewriter, not a computer keyboard, but a mechanical typewriter. None of you have seen this? None of you have ever seen one of those? Okay, well, let me try to draw it really badly, but something like that, right? And what you may remember, if you've ever seen these, is there's something right here. What is that? Anyone know what that is? And an old mechanic. Boy, you guys are really. It's an arm thing, and what it does is you have to use this thing, because what happens is, as you start typing, okay, as you hit keys on here, what it does is it causes a mechanical arm to swing up. So if you hit the A key, a mechanical arm for A will swing up, and there's a ribbon right here. And that ribbon is covered in ink. And what the mechanical arm does is it hits the ribbon, which then on the other side of this is a piece of paper, hits the paper, and it stamps the letter onto the paper. By hitting the ink and then hitting the paper, it stamps the letter A there. And when you release the letter A, that mechanical arm goes back down. Okay? If you hit another character, it does the same thing. Then this thing that I drew that looks like a cylinder is where the paper rolls on. As you type, this thing, which is called the carriage, okay, moves this direction. It actually moves physically. So every time you press a key, it will move over one. Okay? So that will allow you to type the cat ran, because as you hit T, stamps the T, H, it moves over one, then you put the H, it's beside it, right? It's not on top of it. So this is called the carriage, and it moves along. So if you've ever seen those old mechanical typewriters, when you get to the end of the line, this thing will be way over here. It actually moves along back and forth. The reason that arm is there is when you get to the end of the line, actually the arm's on this side, I drew it on the wrong side, you use it to push the carriage all the way back. You return the character back to its original spot. But when you pull that arm to return it, it also does one other thing. It rolls the carriage, it spins it a little bit. The reason it spins it is to move the paper down as well. So what's going on here is you're typing letters into the typewriter. When you get to the end of the line, it will do two things. It will, one, return back to the beginning of the line, and what's called a line feed. It feeds it down to the next line, which is actually two things happening there, which is why under the enter key they draw it like this, because you are performing what's called a carriage return and a line feed. A line feed and a carriage return are the two things that happen when you hit the end of a line, when you press that key down. And what the ASCII table sees is these are two separate characters. Not one character, but two of them. And actually, if you look it up on the ASCII table, you'll see that these are actually two characters, not one. So when you hit enter, it's actually inserting two invisible characters into your file. So let's think about that. You write a poem, because you're a very poetic gentleman. The cat ran to the mat. Beautiful poem, exclamation point. Okay? Let's think about this if you were to save it to a file. Okay? If you were to save this to a file, each of these would be characters. Okay? A T, a H, a E, a space, that's a character. a C, a T, and then one more, believe it or not. Or is it one more? There are two more characters there. There is a carriage return and a line feed. Two characters sitting there. They're invisible to you, but they're in there. And then comes the next line, same thing. RAN space. Let's say I had two spaces. Let's say I was one of those typers that put two. A T, an O, a carriage return, a line feed. And the next line, THE space MAT exclamation point. Now let's say I didn't have a carriage return there. Let's say I didn't. Okay? Oop. Come on. There's one other invisible character there. Okay? There's actually an invisible character there called the end of file marker. That indicates that this file is done. And now, the way you can think of a text file like that is all just one long string of characters. I've drawn them as three separate things here, but I was going to try to use the smartboard to move these up, but it just won't work right now. But right when it gets to here, it would then pick up the R. So all of this is just one stream of characters. Okay? Like flowing water, all of these characters will flow into the file when you save it and when you open it, and the way it displays it on the screen will depend on certain characters that it encounters. Okay? We're going to pause there for today. We'll pick up on this tomorrow, but it's important you get a grip on the way files actually are being saved. Okay, so yesterday we looked at the start of files. Basically, if you think of files as a stream of characters, like I was saying to you guys yesterday, you can think of a text file like this as really a stream of characters streaming in. Sound effects, yes. Including the spaces. Spaces are characters. Including the new line characters. Remember we talked about that yesterday, that is actually two characters. Does anyone remember what the two characters were? There'd be a prize. No, kids. The answer is a carriage return and a line feed. See? At least the sound effects are waking you guys up this morning. Okay, and then another carriage return line feed. And then one other character at the end. Does anyone remember what that one was called? The end of file marker. Okay? But essentially, you can think of a file as a collection of these characters. Now, what else does this look like that you already know about in programming? Where you have a long string of things collected together. Starts with an A and ends in a Y. An array, yeah. Similar, but not the same. Okay. So a file is defined as persistent data. Persistent because it sticks around, okay? Computers will store persistent data on storage device, specifically secondary storage devices such as a disk drive, okay? The processing of these persistent data is necessary so that your software can go beyond just software that runs once. So in other words, it can remember things for the next time it runs. Like, for example, a set of high scores would be in a game. So in Java, this idea of processing data as a stream is a big part of what Java uses for a lot of things. Stream handling is a big part of what's going on here. So I'm just going to turn this over to a diagram for a second, show you what I mean. Okay. So in Java, you essentially have your code accessing a stream. So again, you can think of these as like streams of water, right? But there's more than one, and they're streaming different places. So Java has connections to streams. Some streams connect to files, okay? So in other words, you can dump your data into the stream, and it'll go and get into a file. One of the streams you already know. It's called the system. That's when you first learned Java, you used system.out. You were accessing what's called the default output stream. You were streaming like a string of data to output to just pop it up on the screen. Now, these streams can have all kinds of places. For example, networks, right? If you want to connect one computer to another, that's a sort of stream. The internet can be a stream. So there's all kinds of stream things that Java can access that we can then tap into. And you've tapped into one of them already. You've tapped into the system object. But now we need an object to tap into to connect to files. Now, when I said the word object, okay, what did I mean by that? What is an object in Java? What's another word that's related to object? Starts with a C. It's a class. You guys are asleep at the wheel today. A class and an object are essentially the same thing. The class, as you may have recalled from last year, is the template, and the objects are instances of that class. What are the two main things that every class has built into it? One of them is properties, and the other one is methods. Either you guys don't want to talk today, or you don't, or just not really following this today. Okay? So we need a class object to access files, and that's what we're going to use. So we're going to use these objects to manipulate the files and connect into them. But important with this is the idea that we are streaming to data. Okay? So if you can grasp that concept, you can apply the streams in different ways. Okay? Okay, so it's a stream of data that has a marker at the end called the end of file marker. Okay? And you will write code to file that way, and you will open code from file that way. Okay? And there are three basic stream objects in Java: system.in, system.out, and system.err for errors. You've used system.out before. That was one of the first things you ever did in Java. System.in actually allows you to do basic inputs, but it's not as easy to use as you'd think. So I actually started your basic inputs with the J option pane because, again, as well, you guys want to start diving into graphics a little bit. Okay? So streams allow you to communicate between a Java program and something else. That something else could be a physical device like a disk drive. It could be a connection to some sort of network. Okay? So system.in connects to a keyboard. System.out connects to a monitor or your screen. Okay? But you can redirect these streams, which is what we're going to do. So one of the stream objects we're going to use comes from java.io. Okay, time for you guys to shine now. You've been missing so many questions I've been asking. So here's one. What would I/O stand for? Not on, no. That would be OO. We're talking about files. What would I/O stand for?
Information output?
Close. Input, output. Input, output. Okay? Okay. To access this, we're going to use two class objects. One's called a file reader. One's called a file writer. Okay? These two objects will connect to our file. Okay? And the reason we need two objects is partially because once we start accessing a physical device like a disk drive, we are actually working in a much slower environment than we would normally in our code in general. Because when we launch the code that you guys have been writing, all of it goes up to the computer's memory and just runs that way. But now that we're actually accessing a disk drive, which actually spins using motors, although it spins very fast, it doesn't spin fast enough for us. So we need kind of a two-part connection to this object so that we don't have to wait for it. We can kind of store stuff temporarily and keep our code running. So that's part of the reason why. And part of that is through what's called a buffer object. Now, you may or may not have heard of that term before. Has anyone ever heard the word buffer as it relates to computers? I bet you at least one of you has. Because I bet you some of you have been on YouTube in the last few years. And what does it say when a video isn't loaded up yet often? It says it's buffering, right? Buffers are sections of memory that are essentially waiting lines while it's waiting to get something done. So because we're accessing files and it might be slow, we'll be using an object called a buffer object. Okay? Okay, so the objects we'll be using when we read from files will be the Bufferedreader object and the Printwriter object. Okay? However, before we do any of this, we need to take a second to talk about errors. Okay, so here's kind of what I was just saying in summary. You're going to write your code to do something. I don't care what it is. Let's say it's a game. And over here, let's say you have a disk drive where you're going to save a file. So you're going to save a file to that physical disk drive. So you need to have your code stream your data over there. So actually, let's say you wrote a poem, like I said before. The cat sat. This data file is going to get saved over there. Okay? Well, we're going to need a couple things to do this. Just like if you were saving Microsoft Word, what's the very first thing it asks you? What do you want to call it, right? So let's say we want to call it poem.txt. Okay? So we need to have a file name. We need to have that so that it will save on there. We also need all the data. Okay? So this is the data that we're going to save in there. So we have all the data and the file name itself. And then these things, in theory, will get saved to that thing. And then later, if we want to, say, work on it again, we also want to pull it back so we can open the file. So this would be saving the file. This would be opening the file. So far, I'm not telling you guys anything revolutionary. Okay? But what happens in the middle here is we were accessing classes to do this. And there's actually, as I said before, 2 classes that do this. Not 1, but 2. Okay? And again, the reason is because of this idea of buffering. So that we have one kind of as a temporary and then one that actually accesses it. We don't need this with objects that aren't as slow. But disk drives, physical drives that actually have motors in them that spin around can be slow. Okay? So, some of the objects we'll be using is to save, okay, we will use what's called a Printwriter. Okay? And a file writer. Okay? We will also be using a file reader. Here's the question. What will this missing one be? Printwriter and file writer will save. File reader and, if you think it's print reader, you'd be a good guess, but wrong. It's actually called a buffered reader. Okay? That's the word buffer coming into play here. Okay, so let's think about that. So all of this is going to be working. But, here's the big but. All of this code that's going on in here is potentially very, very dangerous to your computer system. Code that you've written to this point, if it did something wacky inside there, like caused an error, would not be a big deal because it was just your software loaded up in memory. So if it caused some kind of error, it would just crash, and then the Microsoft Windows that's running in here would just keep going as it is. But now we're actually changing something permanent, right? Remember, this was called persistent storage, which is permanent. Or non-volatile was a word I used yesterday. Okay? So the fact that we're doing that, when we're messing with files, Java goes, whoa, 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 whoa. If you're going to mess with files, I need your code to be more secure than the regular code. So we need, around all of this, what's called an error trap. Okay? And it is exactly what it says it is. You set a trap for any potential errors that could happen. And what do traps do? What do mouse traps do? They catch things. They catch potential errors. So this trap is set in case there's an error. So I have to talk a little bit about error traps or error handling before we get into files. Okay? So let me just quickly just show you an example of this in Java. Okay? So this is called error traps or exception. Exception means error handling. An exception is an error, obviously, in your code. And Java uses a format that came from C++, is extremely similar. Okay? There are all kinds of errors you can set traps for, not just files. You can, for example, set traps for running out of bounds in an array, for having a variable overflow its contents, for a piece of math where you'd make a division by 0, using methods with invalid parameters, running out of memory in general. All the kinds of errors that you could normally encounter can actually be set traps for. What this means is your code doesn't necessarily have to crash when it hits this error because you can trap it and deal with it. So I'm just starting you on the idea of error trapping. This might be something you may want to incorporate into something like your final project. And the other one, the one that we need to work on, is file errors trapping. Okay? So there's a couple words you need to know about error handling. One of them is the word throw. When it catches an error, it throws it to another piece of code. Just like throwing a football. It says, oh, we just had an error. Stop what we're doing. Throw it over here and take care of it. Okay? So when you throw something, you also need to catch it. So the error is caught and thrown and handled using these types of terminologies. Okay? So to do this, I'm going to introduce something called a try block. A try block is a keyword that just tries some code. That sets the trap. Okay? And then it's caught with a catch block. So the block of code just says try, and in there you put all the code that could potentially have an error. And then you have a block that says catch, whereas if an error occurs, it will catch it and do something down here. So that something might be popping up a little message box saying a big error has occurred, but your whole program will not crash. It'll catch the error. Okay? And we're gonna do that in the example. Okay? All right. So now I'm just going to show you that these lines of code that are used in the notes here will be used to actually access the file. But now it's time, let's get started on our example. So I need everyone to open up NetBeans. Now here's another big tip for everyone. In the last unit recursion, I didn't get a lot handed in from some of you. The example I do with you is something you could hand in for marks if you don't actually do a programming problem. Why not just hand in the example? If nothing else, it'll give you some points. Some of you have 0 points right now. It's going to be very hard to get the credit in the end if that stays that way. Okay? Okay, so let's set up a project. File, example, or something like that. And you can have it create a main class as well. That's fine. This is not going to be a graphical example. This will be a non-graphical example. Okay. Okay, so what we need to do is set up a bunch of data to save to a file. So let's store it in an array. Okay, so you may recall this is how you make an array. You use the square brackets to define it as an array, not a regular object. And you use the curly brackets to define the contents. So let's make it a 3-line poem. The cat, comma, sat on the mat. Period. Okay? And I'm just going to move that down so it looks like this. Okay. So you can imagine that this is the data file. okay? And that after each, at the end here, there'd be a new line character. There isn't now, but right now I'm storing it as an array. So it's a 3-spot array, like that. And each of these strings is in each spot in the array. Okay? So the cat sat on the mat, period, are going to be in the 3 slots of the array. Okay? So what we're going to write is code to save this to a file, save the array to a file, and then later read it back from the file to make sure that it read properly. Okay? Now, we didn't have to use arrays. We could have used anything. We could have just used one long string of data. But I just thought it'd be a good chance to review arrays as well while we're here. And I'm going to also, for those of you who do not feel comfortable with arrays, because I'm going to be starting that with the grade 11s in a few minutes, it's a chance for you to review arrays in general. Okay? Okay. So as I said before, when you save a file, one of the first things you're going to need is a file name. Okay? Now, obviously, we're not going to leave that as empty quotes forever, but I'm just going to get started with this. And then we'll actually write code to save it. But we're not going to write the code here. Okay? I'm not going to just dump code right here, because that's not good organization. Okay? Better organization would be to write a method that does this. Even better code than that, than to just write a method, would be to first make a class that has a method in it that can save data all the time. Why? Because then I can reuse the class in multiple programming projects. Okay? Not just the method. That's something I taught the 11s just now, that if they take methods from program to program, that reduces their workload. Well, they don't know about classes yet. You guys should know that classes allow you to do this. So here's what I'm going to propose. We're going to make a class called FileHandler. That's going to be the name of the class. Dot, and we're going to put a method in it called save. And we're going to pass it the data and the file name, and it will save this data to that file. But at this point, it has no idea what this class is. So we're going to have to tell it what that class is, and it won't know what that method is. So we'll get to that in a second. It's okay, leave the error, that's fine. So now that we have that, we've thought that there's going to be this class with a method built into it for saving. Let's go back up a line. And let's put file name here as well, or sorry, file handler. That'll be our class there. Dot, and we'll make a method called get file name. Okay. So as well built into this class will be a method that returns a file name. And for that, we'll actually ask our user, please enter a name to save this file. And that'll be a nice way to get a name for the name of the file. So if they want to call it poem, they'll call it poem, whatever. Rather than just type the name in, we're going to ask our user to get involved here. And again, rather than put all the code right here, I'm going to build it into this class. It'll keep things a little more organized. Okay, so let's say that works. Let's say it saved it. Now let's try going the other way. Now let's try to open that file. So just like when you're in Microsoft Word, when you want to open a file, the very first thing it does is it asks you which file you're going to open. So let's use the same variable. File name equals file handler dot get file name again. Okay, but right here, before I go and do anything, these two methods should not essentially seem the same to you. Because right here, when I'm getting a file name, I'm getting it for saving. And right here, when I'm getting a file name, I'm getting it for opening. In some way, we should distinguish between the two different things that are going on here. Now, we could write a method called getFileName for save and getFileName for open. We could change it up that way. But another way we could do this is just add a parameter to this. a parameter that could indicate whether or not we're saving or opening. So I'm going to do that. I'm going to right here in quotes put the word save, and down here put the word open. Okay? So this will now be a parameter of this method that indicates whether I'm getting a file name for saving or whether I'm getting a file name for opening. It's essentially the same thing, but I'll show you later why I'm going to do that. Okay, so let's say that the file now needs to get opened up, needs to actually be opened on my screen. If it's opened, it should return a bunch of data. A bunch of data should come back. This time, why don't we get our data back as just a big string of text? Equals file, oops, my apologies, file handler dot open the file name. Okay, and then finally, to just make sure this worked, let's output that text to our screen to see if this actually did something. Okay, so I know there's got a ton of errors here, but I just want to kind of show you what would theoretically be going on here. So we start with this array called data. It has 3 slots, spot 0, 1, and 2. And inside it is the cat sat on the mat, period. So that's what's sitting in that array. Okay? What we then do is we call a method. We have this big class that we're going to build called file handler. Okay? And inside of it, one of the methods is called get file name. That's one of its methods. But that method requires a parameter right there. And so I use that method with the parameter save. So what it's going to do is it's going to bring up we'll bring up a sort of a dialog box where the user types in the name of a file, and then that name will be returned to here. It will be returned and stored in that variable. So then this file name variable will contain the name of the file, say poem.txt. We talked a little bit yesterday about how the name of a file is more complicated than just that. Okay, but so let's say that worked. Okay, so now that's stored in there. Now we have another method in this class called save, which takes 2 parameters. It takes this data as a parameter, and it takes the file name as a parameter. It takes all that data and the name of the file, and what it should do is it should write this stuff to that file on the actual hard drive of the computer. So somehow this will actually write that on there. And hopefully it should work. Okay? That's the idea. That's what we're going to build into it. Okay, so then that's done. So it's saved the file. That's great. Then it calls this method again. This time it feeds the word open into this. And now, file name, the user will be asked, what file do you want to open? We should ask for the same name just to be sure that it worked. So we'll reopen the same name of the file we just saved, though we theoretically could open any file. So we'll open this file. And then we'll call a method called open from this class. And open takes the file name as a parameter. Okay? What open should do is it should access that file on the hard drive, but as well, open will return right here a whole bunch of text. What text? All of this text will get returned because it will open that file up. And then lastly, just to make sure it worked, I'll spit that text out to the screen. So our task at hand is to write these methods, save, open, and get file name, within a class that we're going to build called file handler. So we're going to build a class called file handler that has those 3 methods in it. And again, the reason why I made it into a class is for more reusability. so that you guys in theory could take this whole class with you and solve problems, or even take that whole class with you and work on it for a final project. Now it's possible that we're also going to build more methods than that into it. But again, rather than just have this example sit standalone as just an example, if you get a little bit more organized with your code, you want to be able to reuse code as much as possible. Okay. So let's just get a quick start at this. You can actually build a whole class just using the light bulb. Notice when you bring that up, whoops, when you bring that light bulb up right there, I can't bring it in, but one of the options is to create classes, okay? Now, another option there is to do an import, which would actually import a class that's already written. We don't want to do that because that's not the class we're looking for, okay? Then it has 3 different options: create class in package, and then some other ones. We actually want to use the second option, create class file handler in package. And what it does is it goes into your code and builds a class. So now when you look at your project window, it should now have 2 Java files in there, because it's just built a whole Java file for you in the package. So that's handy that it did that for us. We jump back to the other one now, and now it doesn't have a problem with you using the word file handler anymore because the class itself is built, but now it has no idea what this method is. So once again, you can use the light bulb and create the method. And do that again with save. Use the light bulb, create the method. And then finally go to here to open. Use the light bulb and create the method. And that'll clear up all your errors in main. But now all your work is here in File Handler. Because now here in File Handler, it has now created the class, and it's created the 3 methods that this class needs to work. Now some of them are return methods, which is why they're giving you an error right now. Like this get file name should return a string, and open should return a string. So for now, just so it won't yell at me, I'm just going to put the words return null in there, just for now, just so it stops yelling at me. Okay? So here again, you can use NetBeans itself to help automate some of your tasks, so you're not the one just writing the code, that it can help do a lot of this for you. Okay. We're going to stop there for today. Tomorrow I'm going to talk about why these methods have the word static on there and a few other things, but we'll just stop there for today. Okay, grade 12. So yesterday we created this main method that in theory should do the following. We have an array of data. The cat sat on the mat. So it is a 3-slot array with 3 parts of a poem in it. We then ask the user, or we will be asking the user, for the name of the file we're going to save. So we're going to say, hey user, give me the name. We will then save the data to that file. We will then ask the user, hey user, what file do you want to open? In theory, they'll open the exact same file. And then we will call a method that will open that file from the computer system and return it as a string of text. And then we'll output that string to make sure it worked. Okay? So this is kind of the theory behind what we did yesterday. This data will be saved to this file name through a bunch of code that we're going to write that's built also, we didn't show this yesterday, inside of a class. We built a class to take care of this. And it'll save it on our hard drive. And then when we go back the other way, when we open it, the same thing will occur to display it on our computer screen. Okay? So that's the process. But again, I want to stop for 1 second and see if you guys remember this from the other day. When we save this thing, we're going to call it poem. But that's not enough. If I call it poem, what's missing from the name of this file? I'll give you a hint. This is just its middle name. What's missing over here? And what's missing over here? The first and last name, right. The last name of this will be whatever we want it to be. But so you guys are familiar with it, we could put something like .txt because it'll just be a text file. Most files on the computer are actually just text files. They just hide that from you. Like HTML is a great example. An HTML file is also just a text file. They just happen to put .html there so that when you double click it, it doesn't open up in something like Windows Notepad. Instead, it opens up in a web browser. But ultimately, it's just a text file. And then the first name for this file will be our path, okay? Which will be like C/whatever, like whatever, okay? So we got to remember that. So now when we get to our code, and we go to our file handler class, and for now, get file name will be very simple. We are going to change that in a couple minutes or tomorrow. But for now, let's give it a first, middle, and last name. So here's what I'm going to propose for now. Let's make a string for the first name, middle, and last name, and then one called file name equal to first plus middle plus last. Okay, and then we'll return that. So we're not going to ask the user at this point. We're just going to code it in right now to get this working. We're going to code in a first, middle, so the middle name we know, it's poem. The last name we know, it's .txt. The first part is the tricky one for you guys because the path where you place this file will depend on everybody's computer. Like right now, I don't think you students are allowed to write a data file to the, for example, the C drive, unless, like Stephen, you're working on your own computer, then that'd be fine, right? That's fine because it's your computer. But I think the network security here at the school might not allow that. So what I might suggest you guys do is just from your desktop, just open up a folder that you know you can put stuff in. Like, for example, you should have a folder with your name on it. And then inside there, maybe you have a folder called My Documents. And you know you can write stuff in here. So I'm going to steal this address from up here. I'm going to highlight it, and I'm going to press Control-C to copy it. Now, obviously, that's for me. Yours will be different. But I'm going to select that and copy it. I'm going to take that to my code and paste it. Okay? Now, notice that when it pasted it, this is a new feature of the new NetBeans, it automatically puts 2 slashes for every slash. Remember, it needs to do that because 1 slash usually means something like a new line character. So 2 slashes is how you actually make a slash. And there's one other thing missing. We need to also put 2 slashes at the very end of this. Okay? So you've got to put 2 slashes right there as well. So really, the name of this file is sjsdfs1.sjst.lcl/staff/lwalk/documents poem.txt, because I am concatenating all 3 of those pieces together to create the full name of this file. The whole file name is there. Okay? So now when I go to save this, that's what it's going to try to do. It's going to save that whole thing. Now, later in this period or tomorrow, we will actually ask the user for that data. But for now, let's just hard code it in. So if we look back here in main, when it asks the user for a file name right here, it's going to return that name. So that's the name it'll save to. And then later when it tries to open it, it'll just use that name. So that's the name it'll open it with. Okay. So now let's focus on save. Okay? The method called save. We want to save data to a file name. Okay, here's what we have. Sitting in this thing right now is an array of three things. The cat sat on mat. That's being passed, an array of size 3. This is being passed to it, which is this long string that has a bunch of slashes, lwalks, poem.txt. That's being passed. So we have everything we need to save this. We have the entire path, the first, middle, and last name, and we have all the data that we actually want to write into that file. We have everything we need to get going here. So let's do that. Let's get going. In the diagram yesterday, I explained that through saving, we're going to use 2 Java built-in classes, but the entire thing is going to be surrounded in this thing called an error trap. So let's set the trap. We set the trap with what's called a try block. You write the word try, and it's called a block, just like an if block, because it uses curly brackets to build the structure around the try block. So the curly brackets are there. And again, you can put your curly bracket here as well if you want. You don't have to put it up there like I did. Okay? And every try block has a matching catch block, like that. And let's say if we catch an error, let's just do system out, and let's just put error. That's as simple as it can be. But that's not enough. That's not enough for this error trap to work. What you need to tell inside the catch block is what type of error are you catching, okay? And what we're catching is one of these, IO exception, and you can use Control Spacebar to help with this. And let's just call it error. Okay. Now there's still going to be a bit of an error there. It'll still probably give you a little red line. But what should have also happened is up top in your code, you should now see an import happening up here. An import line should have appeared up here. And I said this yesterday, so you should be able to get this. No prizes for this one. What does IO stand for? Come on. Input, output, right. So it's an input, output error could occur here. Okay, anyone not there? Okay, so now this is all the code that we need inside there. It's inside the try block where we're actually going to put our code at this point. So inside of try, we put all the code we're about to try to execute. Remember, if at any point an error inside the try block happens, and that error is a file error, it won't crash your program. Instead, it'll come down here to the catch statement and continue along. So that error trap is now set. Okay, so inside the try block, we're going to create an object of type Filename. And again, you can use Control Spacebar to help build this. Notice the capital F and the capital W. This is not an object you're going to be building. This will be an object that will be imported automatically, or you might have to use the light bulb to import it into your code. So this is not an object you write. This is an object that some other programmer built for you. Notice it uses the same style I've taught you. Capital letters, lowercase letters, camel casing. So let's give it a name. Let's just call it writer. Equals a new file writer. Now, at that point, you will notice there are 5 constructors for this class. Okay, and again, I'm reviewing classes a little bit with you guys as we're doing this. 5 possible constructors. So in other words, you can't just make a file writer with empty round brackets. You have to pass it one of these 5. Now the first 2 seem to have as a parameter something that you're not familiar with, a file object and a file descriptor object. Well, we don't know what those are. But the third one looks perfect. All it needs is a file name, and we have that. We already have that. It was a parameter of our method. So that's the constructor we're going to use. Is the third one and pass it our file name, which is kind of what I did in the diagram. So we have a file name right here that is now connected to our FileWriter class. It's actually locked into it through the constructor. But now we need our second object called a Printwriter. And I know you're thinking the word print is weird. We're not actually doing a print to a printer, but what we're doing is we're affecting a stream, what I talked about yesterday. And we'll call this thing file. We have no other good name for it. Equals new Printwriter. And what I put in the brackets this time, I'm not going to go through all the constructors with you, is the writer. So what we're having here is, remember, this is the file name that ends in poem.txt. That thing is passed to our writer object, and then our writer object is passed here to our Printwriter object. From this point forward, all we'll be using is the Printwriter object called file. That's what we'll be using, and actually, it's pretty simple how to use it. To use the object called file, we just go file.print, and it will actually, just like print or print line, it will output the data, but not to the screen. Not like system.out.println. It's not outputting to the screen. Instead, we've redirected this stream, so it's printing to the file. So if I do this print line, and I pass it a string of data right here, it will write that data into the file. So what we have for data, however, is an array. We have an array of data. So to use the array, we're going to use a for loop and go through data.length. So we use the loop, and then we go file.print, and we go print line. Print line will add a line break, and we print data bracket I. So that will write each piece of the array to the file. Write it, write it, write it. So it doesn't matter how big the array is. It could be 3 lines or 3 indexes, or it could be 3 million. It'll keep writing it to the file. But then we actually have one last line of code here. We have to say file, and this is outside the loop, dot close. This line of code right here, file.close, severs your connection to the file. You'd think that that would happen automatically, but Java likes to keep files open in case you need to do more to it unless you tell it to close the connection. So that line has to be executed to specifically sever the connection to the file. So here again is the code that we've written that will execute a file save. So let's see if it works. I'm just going to run my code. And at this point it runs, but it comes back with a null. That's because we haven't written open yet. Open doesn't do anything. But what's interesting is, if I take a look at that folder that I said I was going to save into, which is this folder right here, there happens to now be in this folder a file called poem. And it appears by Windows to look like a text file. So rather than open it in NetBeans, I'm going to double click it, and look at that. The cat sat on the mat. It actually saved it to our text file, which is exactly what we wanted. Now that you guys can write code that can create files, there's a lot of potential mischievery that you guys could do. Think about it. Writing data to files, using loops, potential virus opportunities and things like that, all kinds of crazy stuff. Okay. Should we stop there today, maybe? You think that would be a good place to stop? Or no, why don't we dive into open? Let's see what we can do. Yeah, sorry, Zuhar, which way?
I have like an error where it says static string open.
Oh, yeah, don't worry. We're going to do that right now. Let's do open. It's not that much longer than save, to be honest with you. So let's write open. And believe it or not, it uses most of the same kind of code. Does anyone else need a minute? Okay, let's write open. I had written that line return null. Let's get rid of that. Okay, so open, like save, will have the try-catch block. So you can go ahead and write that, or you can even copy and paste it from the other one. I'm going to copy and paste part of it. Okay? So it starts off the same. Open has the try catch block. Open as well uses similar objects. It uses a file reader object, and we'll just call it reader equals a new file reader, and you pass it the file name. So far it's looking the same, other than instead of writer it says reader. But it's not, as I said yesterday, called a Printwriter. Instead it's called a Bufferedreader. I'll call it file again. Equals a new Bufferedreader, and there I pass it my reader. Okay. So, slight difference on opening. File reader looks similar, but it's this idea of a buffered reader. And again, remember, a buffer is just a waiting line. It's a way to wait. So it's when I'm opening the file that I create this buffer, so that just like when you open videos on YouTube sometimes, especially if you have a really slow internet connection, it might actually tell you buffering video, okay, which means it's reading it in slowly. And that's what we're doing here. We're opening the file, so it's possible that that might be a little too slow for us. So that's why it's created. Because again, I mean, a 3-line poem is not a big deal. A 3 million line poem, that might take a little more time. Okay, any red lights? Any grade 12s? No? All right, we keep pushing forward. So here's the thing. We now can use this file object to do what's called a read. And there's actually several different ways you can read here. Okay? The two that we're going to focus on is read line and just read. Okay? And actually we're just going to focus on read line. Read line, as you can see, returns a string. So it sends back a string of data to you. The reason it's called read line is it reads up to a new line character. So that's the one we're going to use. But we need some variables to make this work. We need a string of text that will start off blank, a blank string of text. We also need a string for our line equal to file.readline. So we'll read in a line of text. But we have no idea how many lines of text are in this data file. It could be 3, it could be 3 million, it could be 0. We have no idea. We need a structure that will continually keep reading until there's no more lines. What coding structure do you know that can do things repeatedly? Right? Now the bigger question, which of the two loops is more appropriate here? That's right, the while loop. Because remember, the while loop is designed for when you don't know when to stop looping. The for loop is designed for a specific number. We have no idea how many lines are in this text file. So that's why the while loop is more appropriate. So we're going to say while line, because we keep reading the line, is not equal to null. Null is how we know when there's no more lines left. If it reads nothing, then we're done. So while it's not a null, our text equals our text plus our line. Plus, we have to add one other thing. We actually have to add the new line character. Believe it or not, read line reads up to the new line character, but it doesn't actually put it into the string. So we have to manually attach a new line to the end of this. So we say text equals text, because we keep filling this text variable up with the line that we just read plus a new line. And then we execute this line. Line equals file.readline. So we read in the next line. So here it'll read in the next line, go back up to the loop, check to make sure it's not a null. If it's not a null, add it to the text, read in the next line. Go back up. If it gets past the end of the file, in other words, it reads a null, it'll leave the loop. And then finally, we have to say file.close. We have to close it again. And because this method is a return method, we return our text. Now, there's still one other potential error. Because this is a return method, you have to add one last line at the end of this that just says return null. That has to be outside of the error trap. So we have one last line at the very end where we return null. Now, if all is right in the universe, and I know I went fairly quickly, so tomorrow I'll do a quick review of this. You should be able to see your poem output on the screen if all is right in the universe. And it seems like such a simple thing that this 3-line poem is appearing on your screen. But what's going on here is way more complex. You saved the poem to a file, then you opened it back up before you displayed it on the screen. So here's the finality of this. Hopefully the cat sat on the mat before we leave today, and the cat sat on the mat. So that is an excellent piece of code that is working there. And we'll stop there for today. And yes, Suhar, if you need, I'll put some more code up on the screen for you. Let's take a look at where we left off yesterday. Now, in my notes, just going to go with the lights off for a sec. Okay, I have another example of the try-catch block and the file reader and the Printwriter and all the other Java classes that we use to write code to file. There is an example of this code in my notes that you can take a look at. But we did our own example yesterday, which I think was a little bit more robust than the one in the notes. But it essentially will read data from files and write data to files. Okay? The one in the notes uses simple input-output boxes, which is fine. But we're going to take it up another notch today. Okay? Hi.
Sorry, I'm in media production, and I'm doing a documentary, I guess, in this class.
Yeah, just one sec. Hang on one sec. Okay, so back to where we were. This is another class I want to introduce to you. We're going to use this in the example today. Another class that's in the Java I/O library is called the file class. And the file class has a bunch of built-in methods that are also good for interacting with files. So I'm just going to show you a couple of them right now, and we'll do a few more in the example. So it has a constructor for building a file. You can build a constructor with a path or with a directory and a file name, which is essentially the path pieced together. There are methods within the file class to do things like, and we're going to use this one today, get the absolute path. The absolute path returns the first, middle, and last name of a file. There's also methods called getName, which produces only part of the file name. So you can see here it's producing the middle and last name of the file. Okay? Then there's one called getParent. And what does getParent give you right here? If this is the full name, and this is the middle and last name, what does parent give you? The first name. Okay? You can use a method called exists to determine whether the file actually exists, because sometimes you're trying to manipulate files that don't actually yet exist on a system. You can get the length of the file in bytes. This is something you see in Microsoft Windows. It shows you how big the file is. So it tells you how many, for example, kilobytes a file is. Well, you can do that now in your code using that built-in method length that's built into the file class. There is a one that can actually return all the names of all the files in a directory. Okay? Believe it or not, directories or folders are files themselves. And I just want to just mention that real briefly. Like, we're used to this kind of system. You have your C drive, then you have a folder that's called like My Documents. And inside there, maybe you have your essay and a picture of your cat, etc. Okay? So this is the kind of picture that Windows gives you or a Mac gives you. But in reality, this is a file as well. That's actually a file. It's a file that's tracking the contents within here, but it's essentially the way the system organizes things. And it's organized into this system, and I'm not just writing this just because it's me. It's called the File Allocation Table, okay? Or the FAT, okay? The FAT, the File Allocation Table, tracks the files. That's what the F stands for. Allocation means where they are stored in memory. To allocate something means to put it in memory. And table is basically how it keeps it organized. But we don't want to see that as users. As users, we just want it organized in a system that looks very visual. The folder system was used because that's the way it was done before computers. You think about file cabinets with folders. So the users got more used to that. By seeing that, they kind of understood a little bit better rather than have some complicated table of data. They presented it to the users in a way they understood. But even directories are files. And that's why when I was mentioning that here, when you get a list, the file itself could be the name of the directory. Like this could be my documents. So when it gives you a list back, it gives you the list of all files within that directory. You can also get timestamps out of this. Like when was the last time this file was modified? And again, you'll see that in stuff like Microsoft Windows. It shows you that date stamp as well. You can rename files. So the file class gives the ability to rename one file to another name. And it also gives the ability to delete files. Now, think about that for 1 second, some of these built-in methods. You can now rename files that already exist. You can delete files that already exist. You can get a list of all files within a directory. You could potentially write a piece of code right now that could go through, with a loop, every single file on a computer system and rename it something like walks rules, or delete them all. So there's potential using files here to cause a lot of damage to the computer system itself in terms of its file structure, its file allocation table, which is why, again, we have things like try-catch blocks to create sort of a safer environment there. Okay? Now, Java recognizes this. When you write a Java application, a Java app, it allows you to do this. It allows you to go through and rename files and stuff. However, you may recall way back that I also said Java can write what are called applets. Applets are Java programs that run on web pages. Applets cannot access files. And think about why not. If you embedded a Java applet into a web page, and then that web page could potentially rename files, that would just mean by going on the internet, you could potentially cause a virus to hit your system. Well, that is not allowed. So Java does have some security built into this file handling system. Okay? Okay. The last thing I want to do, and we're going to do this in our example, is there's another class I want to try to use called the JFileChooser class. Now notice it starts with a capital J. This is very similar to the class JOptionPane, in the sense that it will produce a user-friendly dialog for programmers to use, specifically to choose files. And that's the part of our program that's missing. We can't actually, when we hit save, we don't ask the user where they're going to save it. So what we're going to use is a more graphical version of this called the JFileChooser. And it's going to look like this. It's going to have that similar look to programs that you're used to, like Microsoft Word and stuff like that. It has a slight sort of Java look to it, but it'll allow us to actually save our data to specific files. Okay? So let's do that in our example right now. Okay, so over to NetBeans. And we're going to look at this method that we wrote early on called getFileName. And we wrote in some temporary code to make it work. Well, I want you to get that code out of there. I want you to delete that code. And I want you to rename the parameter. The parameter of this method is whether or not we should be saving a file or opening a file. So I'm going to rename this parameter option. Which option have I chose? Okay, whoops. Okay, so our method called getFileName will have a parameter now called option that will be whether or not we're saving or opening a file. Okay, let's put the code in. There's not that much code to write in here. So we will start by creating something called the JFileChooser. And I suggest using Control Spacebar to bring it up. Once you use Control Spacebar, it should import this to the top of your code. Notice the number of imports we have up top now. We have Bufferedreader, FileReader, IO exception, that's for errors, Printwriter, and now the JFileChooser. Most of these come from the java.io package, which is the input-output package. But file chooser comes from the swing library, the same place where JOption pane comes from, and JInput dialog and stuff like that. Okay, so JFileChooser chooser equals a new JFileChooser. And this one does have the ability to create, it has what's called a default constructor. Okay? So we can construct a JFileChooser with empty brackets there. We don't have to give it any parameters. So we build this chooser object. Okay. Now, what's going to happen, I'm just going to show you real quick, is it's going to, and again, don't type this code. I'm just going to put return null for now, which will at least stop the method. Is we're going to say chooser.show, and it has 3 options for the dialogues it can show. The generic one is just called dialog. That one's not very useful to you. And then it has specifically an open dialog and a save dialog. So it actually has these built in. So for example, if I just say save dialog here, okay, again, don't put that code in there, but I just want to show you what happens now when I run our program. Now when I run our program, this dialog appears, okay? So this is the dialog that we're calling up now from that library. It's a nice dialog for specifically saving and opening, is it creates that nice ability to save our poem to a specific directory, okay? Whereas before we just manually typed in the code, this is going to give us that nice ability to do that. Okay, but what happens is, once the user selects a directory and types in a name, we need to return some results. So I'm going to make an integer called result equal to 0, and then I'm going to start a do-while loop. Okay? So we have a result equal to 0, and I've started a do-while loop. Inside the do-while loop, I'm going to have an if statement. If option, the option which is the parameter up here, if the option dot equals the word open, so if they've sent me the word open in my option, then I'm going to say chooser dot show open dialog. And inside there I'll put the word null. If we were working with a JFrame, a GUI JFrame, I could put the name of the JFrame there to parent my JOption pane, or sorry, my JFileChooser to that object, but we're not doing that, so we're just going to put null there. And then I'm just going to use an else. If I don't want an open dialog, I'm going to say chooser.show save dialog, because it's one or the other. It's the open dialog or the save dialog. Okay, now we need something to control our loop. And the way we control our loop is with this thing result. Well, result is not equal to chooser dot, or sorry, I'm sorry, not chooser. We actually have to, sorry, my fault. We have to use the result. So we have to say result equals chooser.show dialog. So what comes back from the show dialog is a result. And as long as the result is not JFileChooser dot approve, okay. Okay, so let me try and explain what's going on here. So we have this integer called result. That's the result of what happens after the user has used that dialog box. We will either show the open dialog or the save dialog. It doesn't matter. One of those two dialogues will appear, and the user has to select a file or type in the name of a file if they're saving, right? So they type in a name, they select a directory where it's going to be saved. Once they click OK or save or open on those dialogues, it will return a result. The result is actually a number. It's like whether or not it was successful in saving. But basically what I've done is I've forced the loop here that says the user's going to keep getting that dialog box unless they hit the approve option. And the approve is either save or open. That's the approve. So in other words, if they hit cancel, this box should pop up again. So we're kind of forcing the user to save and open properly. So that's what that loop is being used for right now. It's not the only way you could do this. You don't have to use a loop to do this. I'm just doing it just to show off some of the features. Now, at the end of that loop, we create what's called a file object. So we're going to make a file called file. Now this will require you to click on the light bulb and add the import for this. It generally doesn't add it automatically. You generally have to use the light bulb to do this. So now we have one more import up top here, the file class, which is in java.io. So we have all these classes imported now into our code. So now that we have the file, we say file equals chooser dot get selected file. So what that did is it pulled out of the chooser object, the dialog box, the file that the user selected. And they either selected it for opening or they selected it by typing in the name of it when they saved it. Now we have this stored as a file object. It doesn't come back as a string object. It comes back as a file object. Now what we need to do is turn it into a string object. So we can do that right here at the very end with the return statement. We can say file dot, and as I said before, there are several different methods for getting the name of the file built into the file class. Here are some of them, okay? So there's get path, get parent, get name, get canonical path. All of those break up different parts of the file name. Some of them get the first name and the last name. Some of them get, the first name only. Some of them get the middle and last name, etc. But the one we want that gets all of it, first, middle, and last, is the very first one. Get absolute path, which should get totally the path to the file. So I want you to use that one, get absolute path. And that should be it. That will be our get file name program. So I want to show you how it runs. I'm going to run this, click play. Notice how right now it's saying, where do I want to save this? So I'm going to select, for example, the desktop. And I'm going to put a file there. I'm just going to call it poem dot, and believe it or not, the last name of this file doesn't really matter. I'm going to put JPEG, which seems weird. JPG, and I'm going to hit save. Notice now it goes directly to an open dialog. So I'm going to go back to the desktop. There's poem.jpg right there. And I'm going to hit open. And sure enough, it opened it and displayed it on the screen like I predicted. Even though sitting on my desktop right now is what Windows thinks is a picture file. Windows thinks poem.jpg is a picture file. If I try and actually open it in Windows, it won't, because it says, well, it doesn't appear to be a JPEG file. But my program doesn't care. It just thinks it's a text file and opens it as a text file, which is exactly what I told the code to do. Okay? So a lot of data files are just very simple, and how they're interpreted by the program is what works. Now, they're not all text files. I don't want to make you think that. They are not all text files. But a lot of them are. Okay, so this now completes our example. We have 3 methods within our class called file handler. Getting a file name, saving a string array to a file, and opening a file. Hopefully these 3 methods will be stuff that you could reuse in different programs that you try to undertake. I have one more quick thing to talk about. The presentation, by the way, is basically over as well. Right here at the end, it just has another example in my presentation of how to use the JFile chooser, which we just did. So basically, I just want to, for a second, go back to where we started. So we started here by identifying that files are not as simple as you'd think, that they are actually broken up into parts, and that those parts are stored in something called the file allocation table. Okay? We then talked about how files work with classes to stream data to different objects. Streaming to things like the screen is one thing, but now we are streaming our data to files. And we're doing that through manipulating different classes. We drew this really rough diagram of how that would work with the objects and the fact that it was contained within an error trap. But I actually drew up a better diagram for this. Okay? Well, I didn't draw it, but here it is. Okay? So here's your user interface where you're working. And your user interface is obviously working with code. And over here is the place you're going to save data, persistent storage, whether that's a USB or a hard drive or whatever. It's some storage device. In the middle is our try-catch block that creates an error trap around these various objects. So around objects like the JFile chooser and the file class and the file writer, Printwriter, file reader, and Bufferedreader. And the way it passes data between those objects, passing it in the form of strings or as file objects or other types of data. Okay? This might be another way to look at it as well. This is kind of a summary of some of this stuff. Right? So let's read some of this. So here you can see some of the methods built within these classes. Okay? So that the file object has constructors and get methods, delete methods and stuff like that. The JFile chooser has the show save and show open dialog, and it has the get selected file method. The buffered reader, the file reader, and stuff like that. These are essentially the classes that we used, these 6 classes, to actually manipulate files. So we use these classes in combination with your code. Okay?